All right, Aiden and Mackenzie, we got to do example 8. Yeah, this is the last example on 5-7. But for Matt and for Ellie, I'm going to run through kind of like a rough, like this is really quick. When you are adding and subtracting, you have to do matrices that are the same size. If they are not the same size, you cannot add and subtract, and you just do this. Okay? Let's talk about size of matrices before we add and subtract those. So this guy, it goes row by column. So this guy has 2 rows and 3 columns. So he is, I don't know why I put 3. He is a 2 by 3, right? This guy has 2 rows, 2 columns, right? So he is a 2 by 2. Okay. What about this one? He is a 1 by 3. Rows first, then columns. Okay. Rows, columns. There is that. Got it? So when you are adding and subtracting, you have to have 2 matrices that are the same size. Doesn't matter if they're 2 by 3s, 3 by 3s, whatever, they just have to be the same size. So these are both 2 by 2s, okay? So I can add them together all I want, right? And what you just do is you just add cell for cell. So 1 plus 5 is 6, 3 plus 7 is 10, 2 plus 6 is 8, 4 plus 8 is 12. Okay, if that were to say subtraction instead, you would just subtract cell for cell. Now, be careful, like let's say some of these are negatives, right? So it would be 1 minus 5, so that's negative 4. But then I have 3 minus a negative 7. That would be 3 plus 7, so 10. So just be careful of double negatives when you are subtracting, right? 2 minus 6 is negative 4. 4 minus a negative 8 would be 12, right? Okay, so just be careful of double negatives if you have negatives in your thing. Got it? Okay, the next thing is something called scalar multiplication, okay? And it's just taking a number out in front times the matrix, and all you're doing is just,
like foiling, but
yep, so that whole matrix would now be 3, 9, 6, 12. You're just multiplying every cell by that number in front. Scalar multiplication, not too bad, okay? All right, then we have something like we're doing regular old-fashioned multiplication down below, okay? Now, here's the deal. When you are multiplying, let me do a 2 by 3 and a 3 by 2. Okay, so here's the deal. When you are multiplying matrices together, like let's say I'm taking these matrices and I'm multiplying them, okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm just making these like really nice and easy, okay? Let's say this is matrix A and this is matrix B, and I want to multiply A and B together, okay? A is a 2 by 3, 2 rows, 3 columns. B is a 3 by 2. You can only multiply matrices together if their middle dimension right here is the same number, okay? 2 by 3, 3 by 2. That 3 in the middle is the same number. Now, what will happen is, after you cancel those out, I will be left with a 2 by 2 matrix. Okay? 1, 2, 1, 2. It'll be a 2 by 2 when he's done. Got it? Here's how you multiply. Do you remember how you multiply? I'm going to take this first row times this column and add them together. Okay? So I take this row times this column. So I take 1 times 1, which is 1, and I add that to 2 times 2, which is 4, and I add that to 3 times 3, which is 9. And so that top left cell is going to be, what, 14? Okay? All right? Then I do the next one. I'm going to do the top row times the second column. That's going to go in the top row, second column cell, right? Okay? So 1 times 4 is 4, plus 2 times 5 is 10, plus 3 times 6 is 18. And that's going to be like 32. 32 is going to go in this cell, right? Next, I take this row, 4, 5, 6, and I take him times 1, 2, 3. That is the second row times the first column. He's going to go in the second row, first column. And I add them together. So 4 times 1 is 4, 5 times 2 is 10, 6 times 3 is 18. And that is another, what, 32? Okay, last, second row, second column. 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and that's a big old fat number. Like 52 plus 25 is 77. That's what goes there. Just be careful of negatives. It just all is the same, right? So rows times column, rows times column. Got it? Good, good. Okay, let's do this guy down here. All right, so yesterday we kind of read through this, but here's the gist. Look at these three little, like, matrices down below here, okay? What we have going on is in the top thing, we have some options, okay? This carpenter is building houses that are different models, so like different floor plans. We have a floor plan A, we have a floor plan B, we have a floor plan C. And then we have colonial style houses versus ranch style houses. So he's building floor plan A, and he's building 30 of them that are ranch style that are for floor plan A. He's not building any colonial in floor plan A. He's building 10 in floor plan B that are colonial and 20 in floor plan B that are ranch style, okay? He's building 20 in floor plan C that are colonial and 20 in floor plan C that are ranch style to make a total of, I think that's 100 houses total that he's building, okay? So those are like my options that I've got going on here. Now we're going to talk about material that are required. So if we hop down over here, we take that information, we're going to hop down over here. If we have a colonial style house, it's going to cost us 10 units of concrete. It's going to cost 2 units of lumber, none of brick, because we don't put brick on a colonial style house, and 2 units of shingles, okay? Same number of units of shingles for a ranch style house, but it's 5 times as much concrete for a ranch style house than it was for colonial house. It's 50 units of concrete. It's 20 units of brick. It's 1 unit of lumber. That's the number of units, okay? Then we hop over here to the last one when we talk about cost per unit. So concrete costs $20 per unit, right? So if this was 10 units of concrete at 20 units or 20 cost per unit, that would be like $200, right? Okay, so we'd like end up like multiplying those together. Lumber is $180 per unit. 2 units of lumber, that would be $360 or whatever, right? 60 units of brick. We don't have 0, we have 0. If we're looking at 60 units of brick for the ranch style house, that would be like $1,200, right? 25 for shingles at 2 units would be $50 per shingle. I'm guessing these are like in the thousands, but whatever. Okay, so we've got 3 different matrices going on, all right? So what we want to do is we want to start up here with the top with all these Model A, Model B, Model Cs, and I want to figure out ultimately what the total cost is. So what I've got to do is I've got to multiply this matrix times this matrix. That answer, I'm going to take that matrix times the last one and get the final total cost. Do we see what we're doing?
We have a 2 by 4 and a 2 by...
Okay, so we're going to start with P times Q. Okay, PQ. P is a what by what?
2 by 2, 3 by 2.
3 by 2. 3 rows, 2 columns, okay? Q is a 2 by 4, okay? Can we multiply those together?
The middles cancel.
Yes, the middles cancel out, and he will end up being a 3 by 4. That's a huge matrix. All right, I'm going to recopy these down here so that like I can see them. He is 0, 30, 10, 20, 20, 20. I'm recopying these down because then I can see them better. 10, 50, 2, 1, 0, 20, 2, 2. Okay. All right. So there is that. We're going to end up with a, what did we say, 3 by 4? Oofda. 1, 2, 3. 1, 2, 3, 4. I put my blanks in there because it makes it easier for me to think. Okay? All right. Tell me when you're ready. Okay. First row times first column. 0 times 10 is 0. 30 times 50 is 1,500. So it'd be like 0 plus 1,500, so 1,500. Do we see how that works?
Wait. Sure.
Yeah? Now, first row times second column. 0 times 2 is 0. 30 times 1 is 30. And that goes where?
Second.
Right there. Right? Next. 0 times 0 is 0. 30 times 20 is 600. 600. Okay. Next. 0, 30, and 2, 2. 0 times 2 is 0. 30 times 2 is 60. So that's my top row. Okay, now, I didn't mean to erase the 2. Now I can get rid of this top row is done, right? Now I start with the second row, 10 and 20 and 10 and 50. All right, 10 times 10 is 100. 20 times 50 is 1,000. So 1,100. Yeah? Okay, next, that guy times this guy. So 10 times 2 is 20. 20 times 1 is 20. So 40 goes in this cell. Okay, next, I'm going kind of fast. Am I going too fast?
0, 400.
10 times 0 is 0. 20 times 20 is 400.
I like zeros.
Okay, I like zeros, yeah. Now we do 2 and 2. So 10 times 20 is 20. Or 10 times 2 is 20. 20 times 2 is 40. So 60. Okay? And now this second row can be done. And now I've got the third row. Okay? So 20 times 10 is 200. 20 times 50 is 1,000. So 1,200. Okay? Now we're going to go 2, 1. 20 times 2 is 40. And 20 is 20. So 60. Yep. We like zeros.
400.
0 times 20 is 0. 20 times 20 is 400. Okay, last one is, yep, 40 plus 40 is 80. Okay, this is my P and Q.
Now
He is a 3 by 4. Then we have to multiply him by this matrix. So I'm going to write him right next to him,
4 by 1.
which is a 4 by 1.
So the middles cancel out.
So the middles cancel out. So he is, I got to see,
This is going to be a 3 by 1.
20, 180, 60, 25. He is a 4 by 1. So he will end up being, this is really nice, he will end up being a 3 by 1. Right? So I've got 1, 2, 3 by 1, right? And this is going to take a little bit of time. I'm going to draw 2 matrices. Okay, because we got to do a little bit of work. All right, ready? First row times column. Okay, 1,500 times 20 is, holy moly, I need to make this bigger.
I have no idea.
Using a calculator, you could just do them all at the same time.
Do them all at the same time? Yeah, we could do that. That would be smarter. Okay, all right. So 1,500 times 20 is 30 with 3 more zeros on the end of it, right? 30 times 1,800 is 54 with 2 zeros, plus 60 times 600 is 36 with 3 zeros, and 25 times 6. 6 times 25 is 150 with another 0. Holy moly.
Molies. I can't do that.
I'm confused because why do you have 30,000?
1,500.
Because 1,500 times 20 is 30,000.
So
So you're taking each one, like this guy times this guy gives you this one. This guy times this guy gives you this one. This guy times this guy gives you this one. Yeah, it's a
Have you
huge.
just added them up and multiplied, or you just take
You could, yeah,
Would you actually?
yeah.
I
Like
added
if I
If you literally did 1,500 times 20 plus 30
That's what I
times
did.
180 plus 600 times 60 plus 60 times 25.
What'd you get?
What'd you get?
I don't know my calculator.
Oh, I got 72,000.
72,900. Okay. All right. Yeah. Okay. So next row would be this 1,100 times these guys. So you have 1,100 times 20 plus 40 times 180 plus 400 times 60 plus 60 times 25. That old big fat thing. And that goes in the second.
I got 54700.
54700, 54,700.
Yeah, and I got 6088.
Okay, then you multiply the last one, and you got what?
60800.
Each year.
Okay, dollars, dollars, dollars. These are some cheap houses.
Must not be that big.
Hmm.
Hold on.
You can buy that with cash.
Yeah, but that also doesn't include labor, and labor's like half of it. But this is like half of what a normal.
Also,
I
it's
don't
probably
know.
like one of those houses you see in these things. It's like
Wait,
the size
what?
of this room total.
What am I
It's
doing?
ridiculous. It's got like, I have 2 bathrooms, but the bathrooms, and the bedroom, they're the same thing. They're similar.
Okay, so what does this mean right here, real quick, before we stop?
Like the price breakdown
Of Model A, Model B, Model C. So that's the price breakdown with all the units taken into consideration for Model A, B, and C. Okay, you're going straight from model to cost. Okay, so that's the cost for each model. Okay, and again, those are really cheap numbers.
And we're still
They don't have in consideration the labor. I have no idea how big this house
That
is.
also probably doesn't
Huh?
include wiring. 'cause
Yeah,
there's
why,
nothing
like that's not
about-
electrical work or anything.
there's
That
no
wasn't on there.
plumbing working.
There's no plumbing or electric, so.
You
Yeah,
get a
this is
box.
just the bare bones of it, so, yeah.
You want the total cost of each program?
That is the total cost of each one. Yep. Oh, what did they ask for ABC? What is the total cost of materials for all houses of each model?
That's ABC, right?
That's right here. That's our final result.
We don't care.
For each
And then how
kind
What
much
is,
of
for
each
all
would you do?
houses of each model? How much of each of the 4 kinds of materials must be
That's just a
ordered?
3x4, right?
Yeah.
Right, that's just a 3x4 that we already did.
Yes, this one is this right here. What is the total cost of the materials? What is C asking?
You add 3, right?
This is all 3 of those together. What is the total cost of all the materials for all of the houses for everything?
Well, I don't know.
188,400.
400?
Yes.
There you go.
For 3 houses?
For,
Holy
no,
jeez.
actually, that's for 10 houses.
That
Or if
is-
that's for 100 houses.
What the heck?
How big are these houses?
100 home subdivision.
Not very.
100 foot. Wait, no.
No,
That border's 100 feet. So, or 1,000
They
feet.
measure boards in 1,000 feet, but that's not fair.
Oh, concrete is measured in cubic yards, lumber in
1,000
1,000 board
But that-
feet.
That's not, like, that's deceptively big. trust
Yeah.
me.
Yeah. So, whatever. So yeah, these units will be bigger because you'd have to multiply by the thousands and the hundreds and whatever, but
I mean, it used 20,000 bricks, I mean.
yeah.
That's,
Okay, so there you go. But it's matrix
Real
multiplication. It's using matrix multiplication to get to the end result when you have like 3 variables going on. So
What are we doing in this thing?
oh, just solve variables, make an equal. So, like, what does y have to
So,
equal?
I'm sure I have a question. I actually have a couple questions for you.
What does w have to equal?
9.
okay,
Yeah.
all right. I'm gonna stop the video.
It's that
Goodbye.
It's that